Hello, everybody. Welcome to Math 126 online. We're going to go ahead and get started in a minute or two here. Just wait for some more people to join in. So we're going to be going over the syllabus today. And also we got a little lesson that we're going to be doing here at the end. And also I'm going to show you the My Open Math, what we're going to be using for all the homework. So we'll get started with that in a minute or two here. Just wait for some more people to join us this morning. So all of you that are in the meeting now, you don't have to worry about showing your face at all in this class. You can just kind of keep the camera turned off there. You're automatically muted when you come into these meetings, but you can go ahead and unmute yourself at any time if you have a question, or you can also use the chat feature as well if you've got something. So I'll be kind of monitoring that as we go through. So you can ask questions one of two ways. Again, just unmute yourself and ask, or you can also, again, use the chat feature if you have any questions throughout this course. The syllabus that we have here, I'm just going to go through just a kind of quick run through with the syllabus, just to give you the main points, the most important points, and we'll kind of move on. A lot of this is information that you can read on your own. You should have received an email from me last night. I sent it out as soon as the course began at midnight, and that's got a bunch of information in there about the course, some kind of bullet points. Obviously, since you're in this meeting right now, or if you're watching the recorded version of this, that means you've probably already gotten an email and you've already read about it, but we'll go through this anyway. So we'll go ahead and get started. We'll just let people in as we go on. So again, my name is Eric Hutchinson. I'd like to welcome you to this course here. I've been teaching at CSN for 18 years, and I've been teaching Precalculus or trig probably at least once during all those years I've been doing that. So I've been doing this for a while here. So here's the syllabus I'm showing is the web remote version. Now, if some of you are joining me from the pure online class, then your syllabus looks a little bit different, but most of it is all the same information that I'll be going over right now. So here's all my contact information that you see here. My West Charleston office. I'm usually going to be teaching this from home, but if you'd like to meet with me virtually, you can by just making an appointment. So we can always just set up a Zoom meeting, and we'll just set up a time that works for both of us, and then we can just do meetings like we're doing now. So if you have a question on something, please send me an email. Canvas is the primary email you should be using because that's the one I check all the time. But you can also send me an email at eric.hutchinson@csn.edu as well. All the course announcements, if I have to extend any deadlines or do anything like that, I'm going to be sending all important emails through Canvas. So I want to make sure that Canvas is something that you're checking regularly, and you'll be able to know what's going on, up-to-date information with this class. So the first thing that we're going to talk about that's the most important is the website. Okay, so the website for this course, it's linked from the syllabus, but it's www.hutchmath.com. And so what I'm going to be doing here is I'm going to, I'll go ahead and share that website with you here once I actually have it open. So let me go ahead and do that. So now you should be seeing the website that's on the screen. And so this website is the one that you're going to get a lot of information from. So if you go to my website here, you're going to go ahead and see that there's some different buttons on the left-hand side. And so depending on what class you're in, it really doesn't matter. These are both going to be the same notes and everything else. One is your online class, and the WR is the web remote class. So if you click on either one of those, doesn't matter. You'll be able to get the syllabus, but then also you'll be able to get the notes page. So if you click the notes page there is going to take you to where you can get all the written notes and also the guided notes we have for this course. When I do these problems here from home, I'll be doing writing on the PDFs. I'm going to be using the guided notes version. So what the guided notes is, it's got all the problems that I'm going to do during the lecture. They're already typed out, but then there's some space below where you can go ahead and write down notes, and you can follow along as we do the lecture. but I also have written notes. Now the written notes would be the problems are already written out for you. And so everything is all written out that way. And so that's another way. If you miss a lecture for some reason, then you can do that. Of course, these are all going to be recorded and you can always access those at any time. But two different types of notes for you to use. And I have that for every single semester, or every single section, I should say, throughout the entire course. What you're going to notice is there's some of these sections in here, they have a CR next to it. That means a co-requisite review. So there's actually 3 sections of review that we are going to be doing in this course here that would normally come from a Math 126E course, but I'm just going to squeeze in 3 sections for us here, so that way we can do just a little bit review. This is kind of the stuff that is important to go over. There's some things that involve factoring and stuff like that that we're going to kind of review a little bit for you there. So that's on my website that you can do. And also what you'll notice, by the way, is that next to each of the videos, you'll see these examples. These are YouTube videos. And so you can get some more instruction that way. Although since I'm recording all my lectures here, it's probably going to be better just to watch these recorded lectures since they're going to go over the same stuff as these other videos on YouTube. But if you just want to go to a very specific problem, then you can go to that. However, you'll notice in our homework that these videos are also linked as you do your homework problems. And we'll get into that a little bit later when I show you my open math. So that is my website. There's also a link to my open math, and this is going to be where we're going to go for the homework. So we'll take a look at that a little bit later. There's also a link to the tutoring center and about me page. So everything is kind of here for you to use, and it's available there. Okay, so now let's go back to we'll flip back to the syllabus and go through that. Okay, so back to the syllabus again here. Live lecture, you guys already have the link for that. And if you look into the email I sent you and also the Canvas homepage for this course, it's going to give you the link to the previously recorded lectures. So as soon as this is done, I'm doing this live, and what I do is I upload that to my website, and so then you'll be able to have access to that particular video, and I'll be updating those throughout the whole course. All right, textbook. Good news about this course is you don't have to pay any money for a textbook or any learning management system. It's 100% free. Okay, so the textbook we're using here, it's an open source textbook. It's based off of a OpenStax Precalculus book, but I did a heavily modified version of it, and I'm calling it Precalculus Co-Requisite. So Jay Abramson is the original author of that, but I did a lot of customizations to make it match the sections that we're going to be going through here. The book is available from within my open math. I'll show you that later. And my open math is, again, is just it's the way that you're going to be doing your homework online. So the gradebook is in here. The exams are going to be in here as well. There's a gradebook that's in there. So I'll go in there. I'll show you all that a little bit later. So really the only thing that you need for this course is a calculator. Now, of course, since this class is online or web remote, you'll be doing your homework and everything from home. So if you have a cell phone that has a calculator app on it, you could also use that for this as well. But if you'd like to get a standalone calculator, you can do a TI-30 XS Multiview. It's one of them I recommend. It's like a $10 calculator you can find in a lot of places. In the reason why I recommend this one, it's got the math print mode. And so that way it'll display a fraction as an actual fraction and not a decimal instead. So that comes, and then also display exact answers with radicals and stuff like that. So that's a calculator I recommend. Now, if you have a graphing calculator, you can use it in this course. You don't have to buy one specifically for this course, but if you already have one, then you can use it for the homework and the exams. I'm not going to go ahead and read all this for you. You can read this on your own, the course content objectives. You can see all that in here, and the prerequisites and everything else. So here's how we're going to do the grading in this course here. We got the online homework assignments. That's going to be done in my open math. It's 20% your overall grade. The exams are 50%, and then the final exam is 30%. I do grade it on a plus-minus grading scale, which you can see here, and that's really going to be more important towards the end of the semester. I do try and round up where necessary, but I do round everything to the nearest 10th. The withdrawal date, if you need to withdraw from this class for any reason, July 11th is when you want to do that. That's also the deadline to audit the course. I'm not allowed, I can't give an audit or a W as the final grade. Only you can do that by going through the My CSN registration system and changing it to audit or dropping the course if that applies to you. So July 11th is the date that's on that. For grading, basically this is just saying that I do grade on partial credit. I'll talk about this a little bit later, but with the exams, you're going to be turning in your scratch work that goes with that. And so that way, if you make a mistake, even though the computer grades it all right or all wrong, I do grade on partial credit for the exams. Now, you don't have to turn work in for any of the homework assignments. It's just the exams only where I require that. Okay, so basically this just means that you know, even if your answer is correct, if you don't provide any work for it, then you're not going to get full credit for it. I need to see the correct steps and the correct work. Even if your answer is correct, but your work has nothing to do with how you got that answer, then I'm going to take points off as well, because you need to make sure you just have the correct work that supports the answer that you have that's in there. And the work that you show is just basically what we do in class here. I also have some review assignments that we'll go over, and you can kind of see what type of work is typically expected for these kind of problems. So there's no, I don't accept any homework after the due date. I am a little bit flexible during the first week or two since you're getting used to it. If for some reason you can't finish the homework on time, go ahead and send me an email this week and I can adjust that for you. I'm a little bit flexible in the beginning of the course, but then once we start getting into the rest of the semester, this term here, this summer, then I'm not going to accept that there'll be no extensions for the homework. So all this is completed in My Open Math. All the homework is due on Sunday nights. Okay, so we have a first assignment that's due this coming Sunday night that we have. The online exams are timed exams. They're 90 minutes. And then I have a schedule at the end that we'll talk about a little bit later here that tells us when everything is all due and when all the exams are. That's all written here in the syllabus. This is just some general information, no cheating, that kind of thing there. So homework assignments, I touched on this already. They're due on Sunday nights. They're all in My Open Math. The first one's due on this coming Sunday. And there's usually always going to be multiple sessions every week because this is an 8-week course. Unfortunately, we have to go at a little bit faster pace. So a lot of times you may have 4, 5, 6 sections of homework that are due each week. So again, when we get into My Open Math, I'll go ahead and I'll show you how you know which ones are due and when they're due. So we'll get into all that a little bit later. So the homework is 20%. So at the end of this syllabus is the My Open Math registration instructions. And so we'll go over that briefly at the end when we get to it. All right, so for the exams, there's 3 online exams, the tests that are completed in My Open Math here. So you can take these at home, 90 minutes that you get, I told you already. And the average of these make up 50% of your overall grade. We do reviews, and so it's in our schedule of the order of this class. We do have a full review where we go over similar problems on the exam. We do those the day before, the class period before all the exams, we do that. So again, for the exams, I will be talking about this when it gets a little bit closer, but I'm going to send you out like a week before the exam. I'm going to send you a kind of like a template where you can do all of your work on. So the instructions for the problems are going to be in there, but the individual problems will not be, because everybody gets a different version because there's multiple versions of all the problems that you'll get. So everybody has all their own unique tests. But I do give some scratch paper out where you can actually you'll do your work on there, and then you can send it back to you. Now in this class, you want to make sure that you know how to use a photo scan app on your phone, or if you have a scanner at home, you can do that as well. So I only accept the PDFs. So PDF basically is what you want to be able to do. I'm going to send some instructions out. When I send the testing instructions, it'll say some more examples on how to do that, and also give you an example of one of the photo scanning apps that you can use on your phone. If you don't have a scanner at home, then you can have access to that. But basically what you'll do is you're going to go ahead and do as you take the test, you'll just do all that work on a separate sheet of paper. Now, if you for some reason, if you don't have a printer at home, that's fine. Then you can actually use your own scratch paper for that. and you can do your work on regular scratch paper, and then you can just scan that and send it in to me. But that work has to be turned in within 30 minutes of you completing your exam in My Open Math. And so you'll just email it to me in Canvas. So you can just email your work to me that way. And then I will look at that as you go through. And again, if you get the problem wrong, the good thing about that work is a lot of times I'll be able to give you like at least half credit or something on those problems. So you might get a lot of partial credit that you didn't normally think that you would have gotten. So as soon as you finish your exam, don't be too alarmed if your original score is really low, because a lot of times your score ends up going a lot higher than you thought, because I go through and I give you extra partial credit work on that. Now, the same rules also apply for the final exam as well. The final exam is on a Thursday, July 28th, and we've got, it's going to be the same deal with that. So you'll scan the work, send it in to me, and then the final exam is worth 30% of your grade. I do want to let you know that the final exam is a departmental final exam, which means that is written by the mathematics department, but don't worry, because I have reviews for all that as well to help you prepare. So that way you know exactly what types of questions to expect on that, but they're not too much different than the regular exams that we're going to have. They kind of follow the same thing. Okay, so extra credit. Speaking of the final exam, there will be an opportunity for you to earn an extra 5% higher on the final exam with this extra credit assignment. And so this is going to be in My Open Math. It's going to open up like 2 weeks before the course ends. And what this is, it's going to give you practice problems that look similar to the ones that are on the actual final exam. So this will be a really good tool for you to use to do. So basically, if you complete that with 100%, you'll get 5% added to your final exam. But if you only finish half of it, I do give you partial extra credit that's on that. So anything you do will count. And I'll talk about that more when we get into it. So those are the important things I wanted to cover. The rest of this is just information that I'm not going to read. You can read all this on your own. But I do want to mention the Math Learning Centers here. There is a walk-in tutoring lab that is on all 3 campuses. They are meeting in person now and on all 3 campuses. So they're open Monday through Thursday. They're open from like 9 to 6, and they're even open on weekends as well, from 11 to 4 on Friday, Saturday, and Sunday. So you can click on the link that's from the syllabus, or on my webpage, I showed you that I have that button for Centers for Academic Success. That's going to tell you the locations of all those. There's one on each campus. So you can go and take advantage of that to get one-on-one tutoring. Of course, again, as always, if you want to meet with me over Zoom, I'll be more than happy to do that for you. You can just send me an email and set up some time to go over. If you want to go over some homework problems or whatever you want to do, just go ahead, please, and let me know. Okay, so everything else here is just information. Again, you can read all that on your own. If I have to change anything with the syllabus, I will go ahead and let you know that in writing, of course. And so I'll send that out through the Canvas email. So this is the homework schedule that's in your syllabus there. It just tells you which sections are due each week. As you can see here, they're always due these are all Sundays, except for the last week. Everything's due on the Thursday of finals week, because that's the official last day of this course. But everything else that you see here, this is also reflected in My Open Math as well, and you can see, but that just gives you a little schedule. It also tells you the exam dates as well. Now for the exams, I didn't mention this earlier, but the exams are open all day long. So even though this lecture goes from, the listed time from 10 to 11:20 is listed in the schedule, you don't have to take the test during that time. The test is actually open for a 24-hour period. So when you see these days that are on here, that means you got the full 24 hours. You can take it any time on Wednesday, June 22nd, as we're showing here. Anytime throughout the entire day, you can take that test. Now, once you start the test, you can't close the window and then come back to it later. Once you start the test, then the timer begins. The 90-minute timer begins there. So even if you close the window, the timer is still running. And so you can't close it and look and go back into it at a later time. Just to let you know about that. And that's the case for all these exams. The final exam, that's all 24 hours as well that you have. Now here is this is the tentative schedule. This is what we're going to be covering every single day. Now, if we get slightly a little bit off here, then I'll let you guys know, and then we'll modify the homework assignments. I'm never going to assign a homework problem or homework assignment to you if we haven't completed all of it during lecture. So I just want to make sure that, for instance, like this, if we look at up here, we have sections 1.1, 1.2, 1.3, and 1.4 that we're going to cover this week. Let's suppose that we don't finish all of 1.4. Well, then I'll have 1.4 be due the following Sunday instead. So I'll just extend that. So that way you have time after the lecture is done to fully complete that. So I'll be monitoring that. And so if we have to change anything, I'll let you know by email if there's an extension. But every day here is everything that we're all doing. Lecture every day here. We're reviewing the syllabus today. And like I mentioned, we're going to do 1.1 a little bit later. The tests are all in here. We only have one day off on Monday, the July 4th, of course, we got that off. And then everything else is listed here. And so that way you can go to the schedule and kind of know what we're going to be covering every single day. And this is what I'm going to be following as well with that. All right, then we've got at the end of the syllabus, this is the My Open Math registration instructions. Now, in order to be able to register for My Open Math, you need to know the course ID and the enrollment key, and those are both emailed to you, and then you can look at that. Or if you go into the course page in Canvas, right at the top of the page, it's listed there. So whatever course that you're enrolled in, whether it's Web Remote or DE, you'll be able to be in the right section if you look at your Canvas email, because both of those, whether you're in a DE or Web Remote, they do have different course IDs and everything. So as long as you go in, log into your course or look at your email, you'll be guaranteed to be into the right section that's here. So basically, this is what the page looks like when you go to it. There's a link that's right here that says register as a new student, and so that's the link that you want to click on, and then it'll basically go through and ask you to fill in all this information here. This is pretty self-explanatory what it's going to be asking you for. Now, if you're signing up for this for the first time, and you want to come up with a username and password, probably want to use like your CSN username that you use for your email and logging in like that, because it'll make it easier to remember. You can do that. If you've already used My Open Math in a previous course, you might be able to just go ahead and use your same login information, so you don't have to register again with that. And you can just go ahead and add, my particular course that you have here. So again, at the end, it'll ask for course ID and enrollment key. You just look in Canvas to find all that information, all that's here. So that's how you enroll. Again, it's free. Okay, completely free. You can get started today. You can get go in there and do that. So with that, I'm going to transition and just go ahead and go into My Open Math just to show you what things are there. So let me go in. I'm going to just go into the, let's see, I'll go back to my home page here. Okay, so my home page that's here, you can go to the My Open Math login right there, or use the link that's in the syllabus. And once you register, you'll just go ahead and do your username and password every time. So I'll just go ahead and log this in. Now, you're not going to, this page that I'm showing you here, this is like a teacher's page, so yours is going to look completely different. It'll just say courses you're taking, and it's going to list that. But let me just go into one of these, and I'm also going to do a student view here to show you. So when you log into the course, you're going to see something like this. It'll either say 8-week DE or 8-week Web Remote. It's the same course, essentially. It's the same thing. There's always going to be a live class link here. So if you can't find where the lecture link is, it's always going to be in My Open Math. You can click that. And there's also a link right here to the previously recorded lectures. So you can click that, and that's where you're going to go to watch the videos from previously recorded. Again, these are updated daily once the lecture is done. And it does take, just to let you know, it does take about, can take up to a half hour or 45 minutes by the time I post that, because sometimes the processing takes longer on this, depending on what computer I'm using. So just do bear in mind that, check back maybe an hour later, an hour after lecture ends, you should be able to see it linked up there by then. Okay, so this says right here that you have 4 homework assignments to complete by June 12th. Now, besides that, there is also a, oh, by the way, so here are the folders. So there's one folder for every single week of this course, the 8-week course that we have. This is the week that we're in right now. If you want to open up a folder, just click the triangle button, and that's going to open up the everything that you have here. Now, besides the homework assignments that are in here, what you're also going to notice is there's a copy of the notes that are appearing. So actually, you don't even really need to use my website. You could actually just get everything all from within my Open Math here. I put all these in here. The written notes and the guided notes are available for you there. This is the link to the online free textbook, the open source textbooks I told you about. And then you've got the homework assignment itself. It says right here when it's due. Everything's always due at 11:59 p.m. Just know that when things are due at 11:59 p.m., it automatically submits at that time. So you want to make sure that you're done. Particularly, that's more useful for exams. So if you're working on an exam, it will automatically submit at 11:59. So if you start the exam like 20 minutes before the deadline, that means you're only going to get 20 minutes to do the exam before it submits. So you always want to make sure if you're doing exams that you want to start at least 2 hours before, so that way you'll be able to get that turned in on time. All right, so everything that you need is contained in that folder. So it's got all 4 sections, notes, everything is all in here. I also put a tutorial in here. This tutorial is going to be something that helps you to know how to enter answers in my Open Math. This is an optional section, but it might help you to know how to type things in and use the different palettes and the graphing palettes and things like that. All right, so then we're going to go ahead and I'm just going to click on one of these assignments now just to show you what that looks like. We'll just go ahead. These are not timed. So the homework assignments there's no timer on that. And homework assignments, you are allowed to go out of the course and come back to it at your leisure. So you don't have to do all these problems at once. So it's only for the exams you have to do that. Okay, so you can navigate the different questions by hitting the arrow here, by going to question 2, question 3, and so forth. Or you can just click here, and if you want to jump to a particular problem, then you certainly can, and you can put that in. Now, what you're going to notice underneath each of the questions is there's going to be some question help things that appear underneath. The message instructor is what you want to do if you have a question on this particular problem. This is what you want to use, because that's going to send me the exact problem you're working on, and then I'll be able to answer your question. Now, one thing is the My Open Math system actually has its own email system within it. So when you hit the message instructor, that actually is going to send me an email from within My Open Math, and I'm going to reply from within My Open Math as well. Now, the reason why it's better to use the message instructor is because if you try and send me a problem in Canvas, first of all, you're going to have to find out what section, what number it is, and type that in there. And then there's no special palette for instance, when you click on this, notice that there's this palette that comes up here. It makes things easier to put in. When you see that, you don't get that in Canvas. So that's why it's easier just to go ahead and use the My Open Math system in order to do that instead. So this one, you can use a fraction, you can put, something like that in there. So when you submit the question like that, it says that it's wrong. And so notice that right here, this says you have 2 tries on that question. So maybe I'll put that in there instead. If I submit question, it's wrong. If I submit again, it's wrong here. Let me change this bottom number. Okay, so now basically what's happened is I've used up all of my answers on this, and so it won't let me type in anymore. What you can do is just hit this Get Similar Question button. That's going to give you a brand new question. It's going to reset the tries on that problem, and then you can go ahead and put the answer in. Now, if you don't know, if you want to use up one of your tries, you can go ahead and hit Jump to Answer. If you hit Jump to Answer, it'll automatically get you out of that problem, and it'll get you a new one. So you can do that one as well if you want to go ahead and do that. So basically, you can always get, basically once you hit the Show Answer, you can just get this little key right here, and that's going to give you what the exact answer was for this particular problem. And then, of course, you can hit Get Similar Problem, and it'll give you a new one. So basically, you can keep doing this forever, and you can get, not forever. It gives you 97 tries. So I'm hoping that you'll be able to get the problem right after 97 tries. If for some reason you don't, then please let me know. But you should be able to get that correct. And then once you do get the answer correct, then it actually shows up in the gradebook and it automatically gives you credit. So there's no submit button for the entire assignment. When you do these, if you put this in and get it right, I'll go back to the graphing question just to show you. Like for instance, the 0.39. I'll explain this later how I'm doing this, but I just want to show you what happens when you get the problem right. So you get the problem right, it's showing 1 point. This means that you now have 1 point in the gradebook automatically for this problem. So as you go through all these questions, as you get them right, it'll keep giving you credit in the gradebook. So once you're done, if you get all the questions correct, there's nothing to submit. There's no big submit button afterwards. Then that whole assignment's done. Then you can just go ahead and move on to something else. And these assignments, by the way, you don't have to do these in order. If you want to start on one of these and then jump to 1.4, certainly you can do that. Of course, you probably want to make sure you have the notes for it first before you attempt these. But you can do these really in any order here on that. And so there's also below here, there is under student resources, there is the textbook that's going to take you to, let's go ahead and take a look at what the textbook looks like. The textbook is the Precalculus co-requisite course here, and you can see all the different, there's some review sections that are in here. I don't have the notes updated on my website just yet because I'm actually working on this over the summer because I'm teaching Math 126E in the fall. But if you want to go back and review something, the textbook is all complete. So you can jump to any of these particular sections if you want to review something. But all the sections are listed here. But if you go back to the individual folders that are in here, the particular section you need to be concerned about is automatically linked for you for the textbook. So you don't have to hunt down the whole thing. They're all kind of broken up because each section is a different web page. So there's also some other helpful websites that you can use for this course. They have other videos and different things for you. There's also some online graphing calculators and things for you to use there as well. So that pretty much is just a summary of everything, the syllabus and what the course is going to be. Again, all your homework is going to be done here in My Open Math as well as the exams. Now, if you go to the gradebook, I can't show this because I'm a teacher doing a student view, but you're going to be able to see on here, it's going to display what you've done, what you've attempted so far, what your score is, and you're always going to be able to see what your breakdown is. After all the exams are done, I'm going to go through and give you partial credit. And so then once that's all done, you'll see that updated in the gradebook, and it'll keep track of your score throughout the entire semester. So you always will know what your score is going to be at any time with this course. And so again, the messages link here, you're going to see something, a number appear next to it. It'll say new or a number to show you how many messages. That'll let you know if I've replied to your homework request email that's sent, and so you can use it for that one. So I'm only using the messages system in here just to answer homework questions. Again, all official announcements for this course, they're going to use Canvas. When you turn in your written work for the exams, then you can use Canvas as well. Again, I do not require any work for the homework problems at all. So just the exams only, the test 1, 2, 3, and the final exam, I require written work to be shown for that. Otherwise, yeah, it's just you just do the homework online and submit it, and that's how you'll do that. So at this point, does anybody have any questions over anything I've talked about so far? Anything about the syllabus or about the My Open Math itself? I'll just give a couple seconds. Does anybody have any questions on that?
Quick question. So for the exams, we are going to be recorded, right, during all of them and our final as well, and timed?
So you're going to be timed, but I'm not using ProctorU for this course. So no, it will not be recorded.
Okay, and as far as the scanning, there's an app on our phone that we can just scan it and email it to you. Is that going to be accepted as well?
Sure. Oh yeah, that's fine. So the scanning app, a lot of those will just turn it into like a PDF, a digital copy like that. And so you can go ahead and scan and turn it in. Now, if some of you want to use like what I'm going to be showing here, when I do my notes, I have a digital writing pad. So if somebody of you guys would like to do that right on top of the PDF and handwrite it using a digital pen or something, that's okay too. Then in that case, you wouldn't have to scan anything. You would just do all your work with a digital writing tool. But sure, if you have a scanning app on your phone, that's perfectly fine to use that.
Okay, and then one last question.
Yeah.
For the lectures, if we can't attend them for work or for whatever reason, they're always going to be recorded, correct?
Yeah, so on this, when you go into your course, you can just click the previously recorded lectures button, and it's going to show all the lectures here. Now, these right now, if you click on any of these links at this point, it's just going to take you back to the same page again. So if you click that and it takes you back to the same page, that means I haven't updated it yet. But then it will be updated afterwards. But yeah, you can go to any date here and you can just click on it after the lecture's been recorded, and you will be able to watch the whole thing.
Okay, awesome. Thank you.
Yeah, so that'll be from within my open math. Anybody else have any other questions about the course or the syllabus before we get started with? I want to answer these questions first before we move on to the lecture. Anything else? Any other questions? Just a little bit about me. So if you go to the About Me page that's here, this gives you a little information about me. Again, I've been teaching at CSN for 18 years. Some information about me. I've got a little Maltese puppy that I have. That's my dog Snowball. I also play percussion. Well, kind of play percussion at the Crossing Church. I don't play very much right now, but I used to do a lot with that. I was part of the worship band. And I ride a bike for exercise. And so I have a folding bicycle. This one here fits into my trunk of my car. So I like to do some trails around. I go to the Mountains Edge Park and do that. Although now it's getting a little toasty. So I'm probably going to be doing more inside exercise bike stuff, but I've been trying to do that. I've been on sabbatical actually for the last semester. So I did not teach in the spring, and now I'm starting to get back into the teaching again. I'll be back full time in the fall, but I'm going to be basically my project that I'm working on was all the materials for Math 126E. So all of the videos and the notes and all that stuff and the homeworks, everything's going to be done by the fall. So that's my project this time. So this is now my first time teaching since December. So it does feel good to be teaching again for sure. So with that, I'm going to go ahead now and I'm going to go to the notes that's here. So let's go back to the written notes. So now you should see the PDF that's over here. And what I'm going to be doing is just going through this notes. Anytime, if you have a question as we go through these notes, again, you can either use the chat or feel free just to chime in and just ask a question. You can unmute yourself and go on in and ask a question that you have with that. So for now, we'll get started with that. And so every time now for the rest of the course, basically we'll just be going through problems for the lecture, doing it this way. So this is basically I'm just using a PDF and I'm using the commenting feature on it. And I'm just basically gonna be writing on the same guided notes that you would have to work with. Now, sometimes there's some weird things that happen. There's some little boxes that appear for no reason on here. So just ignore those as we go through. It's just one of the limitations of using this particular system, but this works pretty well. And so that's why we're going to be kind of using this. So get started here. 1.1, we're beginning with the distance and midpoint formulas. First thing I want to do, though, is review plotting points. If it's been a little while since you've done that. Of course, there's a Cartesian coordinate system, it's called, or sometimes it's called rectangular coordinate system. But there is an X that's the horizontal axis, and you have Y as the vertical distance here. And the quadrants are labeled here for you: first quadrant, second, third, and fourth. So that way, in case it asks you for what quadrant something is in, you'll be able to tell where it is just by looking at the numbers that are listed around there like that. So what we're going to do is we're going to plot this. Now, the way that you plot that is the first number on top here So this is the X. So here's that little box I told you about. Sometimes that appears because we're using the commenting feature. Again, just ignore that. That usually goes away as I do other stuff on here. But anyway, X and Y, the first coordinate is the X, the second coordinate is the Y. What you do is you start at 0, 0 always when you plot something. If the X coordinate, the first coordinate, is negative, you're going to go to the left. If it's positive, you're going to go to the right. Then for the Y coordinate, that's the up and down. So for the 4, if it's positive, you're going to go up. If it's negative, you're going to go down for the Y. So if I want to plot -1, 4, I would start at 0, 0. I'm going to move 1 to the left, and I'm going to go 4 going up right there. And so that point right there, I'm going to go ahead and label it -1 and 4 right there. And that would be considered the second quadrant if it asked you first, second, third, fourth. It goes counterclockwise like that. Okay, now the next one is -4, -2. Again, we always start at 0, 0. -4 means we're going to go 4 places to the left, and we're going to go 2 places down because they're both negative. So we go to the left and we go down. So right here, that point right there would be -4, -2. Okay, so that's that point. Next one, 3, -2. Okay, so from here, just because 3 is positive, we have to go to the right this time. So we're going to go 3 places to the right and then down 2 units to here. Okay, so that's going to be 3, -2. Okay. So this was in the second quadrant. The next point was in the third quadrant. Now we're in the fourth quadrant. 3, -2 was the fourth quadrant. All right, now we have 0, -3. Now 0 means we don't go to the left, we don't go to the right, we stay on the y-axis, and then we're going to go down 3 units. Right there, that is 0, -3. That's actually not in a quadrant. Okay, so it's not, anytime you get something that appears on the axis, on the x-axis or the y-axis, we don't have it considered in any quadrant. So, no quadrant there for that one. Then we have 2, 3. So to the right and up 3. Right there. So 2, 3. That's it. Okay, so that's how you plot all those points. Just a quick review over that. Again, you always start at 0, 0 and go left or go right, up or down, depending on whether it's positive or negative when you look at that. So that's the 5 points labeled there. The point 2, 3 here, that would be considered in the first quadrant. All right, let's go on. We'll go on to the next thing that this talks about is the distance formula. All right, so the distance formula here. So let's suppose we wanted to plot these 2 points, -2, 1 and 1, 5. Okay, what I would do is I would go ahead and plot the points. These are already done for us right here. So from the 0, 0, we go 2 places to the left and up 1 unit to get the -2, 1. We have 1, 5 over 1 and up 5 to get to that point. And then what's done there is we're going to make a triangle out of those points and then label the sides of the triangle right here. Now, the reason why we're doing that is because there's something that's called the Pythagorean theorem. Get rid of that box here. Okay. So a squared plus b squared equals c squared. That is called the Pythagorean theorem. This is used to find the missing sides of a right triangle. It only works with right triangles. That's what we have here. That's actually why we created specifically a right triangle. Now, if we count the number of boxes here and here, technically we start at 5 and we subtract 1 and we get 4, or you can just simply count the boxes. There's 4 of them here and there's 3 of them here. Now the C is actually always the longest side of the triangle. So if I put this in here, I have 3 squared plus 4 squared. So the A and the B, it doesn't matter which one. The thing that makes the most important thing is that the C has to be the longest side of the triangle. That's your hypotenuse, or that's the side opposite the right angle. Okay, so that has to be your C, but A and B doesn't matter the order on that. So I'm going to do 3 squared plus 4 squared equals C squared. And I'm just going to solve for C. Now, when I solve for that, that's going to tell me how far the distance is between -2, 1, and 1, 5. That's what I'm trying to find. The whole point of this is trying to figure out how far that distance is. So I have 9 plus 16 equals c squared. That's 25 equals c squared. And then I need to take the square root of both sides. Now, normally when you take the square root, you get plus or minus on that, but because I'm only considering the a triangle that has a positive side on it, I'm just going to take the positive square root of that. So I'm going to take the square root of both sides. I'm taking the square root, so it cancels out the square there, and I get 5 for C. So now I know that that is the exact distance between these 2 points. It's going to be 5. So this is one way that we can find the distance between 2 points. We can plot the 2 points, draw a triangle, and then go ahead and go through all that work there to get the answer. But the question is, well, what happens? Okay, well, we can do that, but what if the point is like, if it's like 28 comma 99, and then we have a 101 comma something else that's really big like that? We don't want to have to draw a huge thing for something that's that big. So we want to come up with a formula instead, and that's what we're going to come up with here. It's called the distance formula. And so I'm going to derive it here for you. So what we're going to do is we're going to draw another, this could be some different points, x1, y1 I'll put here, and I'm going to put x2, y2, the other point. So even though it looks the same as the picture above, we're just going to make this generalized. So maybe we don't know exactly what these points are. So I'm just going to label in general x1, y1, x2, y2. Now, just like we did up here in this previous example, to get that side, we counted the number of boxes, but we can also do a subtraction here. Take that y value up there and subtract the y value down below. So 5 minus 1 will give you 4. Well, I could do the same thing here. If I subtract that, I get y2 minus y1. So the y2 that's here and subtract y1, that's that distance there, y2 minus y1. Then I have the x, I can do the same thing with the x's. So I can do x2 minus x1 down below there. Now I'm going to use the same exact formula that I used before. I'm going to use the a squared plus b squared equals c squared formula, just like that. As I mentioned before, the a and the b are going to be these vertical horizontal sides. The c has to be the longest side of the triangle. Now ultimately, in my picture, I'm going to go ahead and put a D there because D stands for distance. So if I put this all into the Pythagorean theorem formula, I'm going to get x2 minus x1 squared, and then I have y2 minus y1 squared, and instead of a C, I'm going to use the D that I have here, and I have D squared from that. So that's using the same formula I had from before. Now, what if I want to take the square root of both sides? So, okay, we did that before up here. We did square root of 25. Unfortunately, I don't know what the x's and y's are, so I just have to keep that as this. So let's go ahead and write this out first. Squared like that, and then I'm going to do square root of d squared just like that. Now, because there's a plus sign that's separating this, I'm not able to cancel out the squares from each of these. I could only do that if I had multiplication or division inside the square root. Now, since I don't have that, I have a plus. If it's plus or minus, unfortunately, you can't do that. So I cannot do any more to simplify this. So therefore, here is going to be my final answer. It says down here, distance formula like that. It's this d equals the square root of what I just have inside here. So again, I can cancel out the square root and the square, but that's about all I can do as far as simplifying. I can't do any more inside the radical here. So again, the reason for using a formula is that way I don't have to worry about trying to plot the points all out and spend time doing that. I can just simply plug the points directly into the distance formula. Now, it doesn't matter which point that you label x1, y1 and x2, y2, it makes no difference. Okay, so let's do an example by using that distance formula. So it says use the distance formula to find the distance between these. So These 2 points that are labeled here, it doesn't matter if I want to put x2, y2 here and x1, y1, but in fact, let me go ahead and label it this way. This is different than what my notes have. So let's change this to x2, y2 and x1, y1. The only thing that you're not allowed to do is you can't do like x2, y1 or x2, y2. You can't. You have to make sure that these are both 2s or both 1s. You can't mix and match those. Okay. So now I have it labeled x2, y2 and x1, y1. I have these points labeled as such here. The distance formula, we have it listed out for us. So let's go ahead and plug in the information from each of those, x2, x1. So we have that label. x2 is the -2 and the x1 is the 1 that we have. So let's put those numbers inside here. We're going to do -2 minus 1 squared. And then we're going to do y2 minus y1. We're going to do 4 minus 6. Just like that. So I'm just labeling my, plugging in exactly points that I have that I labeled up here. So that's done for us. Now we're going to simplify that. -2 minus 1 is going to be -3 squared. And then 4 minus 6 is -2 squared we have in there. Our order of operations says that we have to square these first before we add them together. So we're going to do 9 plus 4. And that's going to give us the square root of 13 as our answer. Square root of 13, we can't break that square root down anymore. So we're going to type that in. When you put these into my open math, it is going to ask for the exact answer. So you don't want to change this to a decimal, because a decimal is actually not considered an exact answer. You do want to put square root of 13 and whatever it is in there. Now, let's say if it was square root of 24 or something like that, you could break that down further. But again, usually my open math would accept that if it's not completely broken all the way down. But most of them you'll see are ones that cannot be broken down like this. So square root of 13, there's nothing more I can do with that. So I'll leave my answer as that. In fact, sometimes you might even get a whole number answer, depending on what the problem is that you're going to be doing in here. So that's the end of that one. So let's do, we're going to move on to the midpoint formula next. So we talked about the distance formula, just like that. We've already seen 2 examples of that. This one we drew a triangle, but certainly we could just throw this right into the distance formula and get the direct answer as well. But now we're going to move on to midpoint formula. Now, the way the midpoint formula works is you basically have, if you have something drawn like this, and again, let's see, get rid of that. Okay, so if I have 2 points that are here, and I'll do x1, y1, and x2, y2, like that. I have a line connecting those. But let's suppose I wanted to find the exact halfway point on that line. So I want to find the halfway point. This is actually called M. This is going to be your midpoint is what I'm doing on that. Now, the way that we're going to do this is we're basically going to take the average of the x values and the average of the y values. So basically add the x values together, divide by 2. That's going to get you the middle point right here. You can do the same with the y values. Take the y1 plus y2, divide by 2. So notice that this is different from the distance formula. The distance formula had minus signs on it, but the midpoint formula has plus signs because, again, we're doing an average. And whenever you want to do an average, you're adding things together and dividing by the total number of how many there are. So I have the x's I'm adding together, dividing by 2. So that's what I have here. Okay. So my answer is going to be some kind of coordinates. I will get an x and a y as my answer. So I'm always going to answer this with a point. Whereas distance formula, you're going to get some number left over. Midpoint requires you to write an actual point. Now, when you write these in my open math, if you get something up there that says invalid notation, then probably that means you forgot to put the parentheses around something. So when you type your answers into my open math, you do make sure you have to have the parentheses around it. In other words, if we didn't have the parentheses around it, we just had 2 comma -3, well, then we wouldn't know that's a point. That might just be a list of 2 numbers. So that's the reason why the parentheses are needed to indicate that that actually is a point. Okay, so now let's go ahead and do this. We're going to do the same labeling again. Now it doesn't matter. Last time I did x2, y2, and x1, y1. It doesn't make a difference. If I want to do x1, y1, x2, y2, that's okay as well. So I don't need to, doesn't matter the order in which I do that. But let's go ahead and write it this way. x1, y1, x2, y2. I'm going to use the midpoint formula, which is listed right here. So m equals, okay, let's put this in. X1 is 2, x2 is 4. That's all added together divided by 2. Next, I have y1 plus y2, so I have -3 plus 2 all over 2 as well. So I'm adding up the y values, 2 y values I see here, and then dividing them by 2. Now I want to simplify this. So m equals, all right, so I have 6 over 2, which is 3. -3 plus 2, that's going to be -1. -1 over 2 there. And I can leave my answer. The negative I can either put on top or out front. It doesn't matter. But this is going to be my answer 3, and -1/2 is my answer on that. So that would be the exact halfway point between these two right there. So even though it doesn't ask you to do this, I'm just going to go ahead and plot this for you, just so visually you can see what it is we're actually doing here. If I want to plot, and this is also a review of plotting. So if I wanted to plot this, I have 2, -3. I would go 2 places to the right, and then I would go down 3 units to here, and then 4, 2. I would go 4 places to the right, and then up 2 units right there. The line drawn between those, that would be a distance if it was asking for it. That look a little bit straighter if I can here. Yeah, kind of hard to write with this digital tablet on that, but you get the idea. Okay, the point, midpoint would be 3 and -1/2, which would be about right here if I was to plot that. So that does make sense that our midway point is plotted correctly. 3 and -1/2 would be about right there. That makes sense that that would appear on that particular line. So that's essentially what we're doing. We're just finding the point that's exactly halfway between the other 2 points, just like that. Okay. All right, now we got some other questions that are going to appear in this homework assignment. So let's go through some other types of questions that you'll see in the My Open Math homework. Okay, so here's another one. It says, if the point 11, 14 is shifted 5 units to the right and down 2 units. Okay, so we got to go 5 to the right, and then we got to go 2 units down. So we're taking a point and we're moving it 5 over and then down 2. Okay. What are the new coordinates? Okay, now you don't have to worry about even plotting this. You don't have to plot 11, 14 and physically move it. You could, if you had graph paper, certainly you could do that. You could plot 11, 14 and then physically move it over to get the answer, but you don't have to. Now, let's talk about what it means if we're moving something 5 places to the right. We have a point we're moving it 5 places over. That means that the x value, we're going to have to add 5 units to that. So if I'm at 11 and I add 5 to it, that means it's going to shift over to 16. That's what it means by that. If I'm moving it down 2 units, that means I'm going to subtract 2 units from this. So whenever I go down, the number is going to get smaller as I go down that way. So essentially what you're going to do here is you're going to take 11 and you're going to add 5 to it. And we're going to take 14 and subtract 2 from it. Now, if that was moving it up 2 units, then I would be adding to 14, but instead I'm moving it down. So this is what I'm going to do. I'm going to add 5 units to the 11 and subtract 2 units from the 14. That's going to give us our answer of 16, 12. And that's all you would put there for your answer. That's where the new point would shift to. It would move 5 places to the right and then down 2 units. You just enter that 16, 12 as your answer. Okay. Let's do another one of those, even though I don't have it. I don't have it on my notes here, but I'm just going to make up another problem here. So let's go ahead and put another example. I'm just going to write this in. Let's start with the point let's do -3 and let's do -3, 7 is shifted. Let's do 2 units to the left this time, and let's move it 8 units up. Okay, so let's do that problem. So it's like the same one, but we're just doing a little bit different. So starting with the point -3, 7, we're going to shift that 2 units to the left and then 8 units up. Okay. All right, so if we're shifting it 2 units to the left this time, last time we added, but if it's shifted to the left, that means we're going to subtract actually. So we're going to do -3 and we're going to subtract 2. And then for the 7, we're going to shift that 8 units up. All right, so 8 units up means that I'm going to now add that to the y coordinates. Last time we had 2 units down, we subtracted, but now because 8 units up, we're going to add that to that one. So if we do that one, we're going to get -5 and 15, which should be the new point. So I just wanted to make up another example for you there because just so you get a little bit more variety on that one. So with that, since we finished the notes on 1-1, I'm going to go ahead and show you my open math just to show you that the questions that we do for the homework are going to be very similar to the ones that you see in the lecture. So that way you always get the right amount of notes for that particular one. So we finished these notes here, but I'm going to just jump back into and show you the homework in there. Let's go into the back over into the first screen here. And in the My Open Math, which you should see now in there, if you go ahead and look at the problems that are in there for the distance and midpoint formulas. So we already did this one I showed you guys earlier with the plotting points. That's kind of the first thing we covered in our notes there. And then now these are getting into the distance. And so these here that are in the homework, you could actually draw a right triangle there and use the Pythagorean theorem on that. Or if you want to go ahead and use the distance formula, that's okay to do that as well. And so here is the some other ones there that are already plotted for you. Now this one is getting into midpoint. Midpoint we just talked about there, where you just type in the answer for that one. And then here's one of the problems that we just did. 3, 6 is shifted 2 units to the right and 4 units down with its new coordinates. And so then we've got that in there as well. Here's another one that's got a 2-parter that's kind of doing the same thing that we just talked about before. And then that's it. That's the whole entire homework assignment. So just letting you know that I try and make the problems in the homework are very similar to what we go over in the notes. And so that way you know exactly what it is that we're doing. And so that's the reason why we have that. So up to this point, does anybody have any questions up to here? So anybody have any questions on that? So if nobody has any questions, what I want to do is I'm actually just going to do a little bit of 1.2. I usually try and end class always at 10 after, so that way we have 10 minutes if anybody has any questions or wants to ask any questions afterwards. We can do that, but I'm going to go ahead and move on to 1.2 anyway. Oh yeah, we got a question in the chat here. Nobody has a question? All right, so let's go ahead and then in that case, I'm just going to do like maybe 5 minutes, just 5 more minutes of this, because I want to just make sure we have enough time to cover everything so that way we have time to cover everything for this particular week. Again, if there's a problem and you need me to explain something over again, if I'm going too fast, please let me know, and I will go ahead and explain something over again, and we can still jump back to the the other section as well. If you need to ask something on that, by all means, go ahead and ask on that. But we'll go ahead and just jump to 1.2, and we'll just start this section. We're not going to finish it today, but we'll continue it tomorrow. You should have all the tools that necessary to do 1.1, so you should be able to complete all of 1.1, now that we've covered all of it. But let's go ahead and jump into this. So 1.2 is talking about graphs of equations of two variables, intercept symmetry we'll talk about tomorrow. So the first thing that talks about here is talking about intercepts, how to find X and Y intercepts. Now, of course, you can read those off of a graph, but if you don't have a graph written, then this is the rules for finding that. To find an X-intercept, you're going to put a 0 in for Y and solve for X. You want to find the Y-intercept, you put a 0 in for X and solve for Y. So we're going to do that for this particular question. Again, these notes that I have, these notes are all coming from the from within My Open Math. They have the guided notes. So you want the guided notes because that has these spaces that I'm writing on here. That way you can write on that as well and follow along. Okay, so find the intercepts for this right here. And so here's the rules. If you want to find the X-intercept, you're going to put a 0 in for Y and solve for X. Okay, so let's put that in there. I'm putting a 0 in for the Y, just like that. And then I want to solve for X. So this is 0, so I have 4X equals 4 right there. And I'm going to divide both sides by 4, and I get X is equal to 1. Now, writing this as a coordinate, okay, there's a 0 for Y, and we got a 1 for X. So if you want to write this in coordinate form, you'd write it as 1, 0. The Y is 0, but the X value is 1. So that's our answer, 1, 0. Okay. So if we want to find the Y-intercept, put a 0 in for X and solve for Y. All right. So we put a 0 in for X. Like that. We're using this formula, same formula again. A 0 in for X, and we get Y squared equals 4. So 4 times 0 is 0, so that goes away. Y squared equals 4. Now here's something that's important. Whenever you have a square like that, you want to take the square root of both sides. Remember that you're going to have to do you're going to get plus or minus on that. So Y equals plus or minus the square root of 4, which means that I get Y equals plus or minus 2 is my answer. The way you would write that is you would put a 0 in for X. So 0, I get a 2, but then I have a 0 and negative 2. So the X's are zeros in both these cases, but I got a positive 2 and I got a negative 2. So this is how you write it as a coordinate. When you type this into My Open Math, whenever you have more than one coordinate like that, you want to separate them with a comma. Okay, so you put the first one in there, put a comma, and put the second point in there, and that should give you the answer. By the way, if you have any issues with entering problems in My Open Math, or maybe My Open Math marked you wrong for something that you believe is correct, please send me an email and let me know that specific problem. I can go into the gradebook and see the exact problem that you attempted, and I can make sure that it graded it correctly, and I can let you know that there was something that was off on that. There shouldn't be any more issues with My Open Math marking you wrong for something, but if you find something like that comes up, please definitely let me know, and I will fix it and take a look at what that is. Okay. All right. We'll do one more of these here. So now we have this is a little bit different. This is an absolute value. Now this might require us to review a little bit here because you may not have seen absolute values for a while, but we'll still go through that anyway with this. Okay, so if this one, put a 0 in for Y and solve for X, we want to find the X and the Y intercepts here. So X-intercept, put a 0 in for Y and solve for X. 0 equals absolute value X minus 4 minus 5. Okay. Now for this, we're going to, whenever you have a absolute value, you want to always isolate the absolute value like that. So what I'm going to do is I'm going to add 5 to both sides like that. And I get 5 equals the absolute value of X minus 4. Or of course, I can write it as x, absolute value x minus 4 equals 5. That means exactly the same thing. Now, in order to solve this, what you're going to do is you're going to have to write two different equations. Now, remember what absolute value is like, for instance, absolute value of 5 is 5, and then absolute value of -5 is also 5. What that's doing is absolute value just basically tells you how far that number is away from 0. And so if you're just talking about number of units away, both 5 and -5, both of those are 5 units away from 0. That's what absolute value is telling you. So it's always a positive value. So therefore, you're always going to get two answers. So if you have a 5 on the side, then either you have a 5 inside or a -5 inside. That gives you the same answer. So because of that, we have to set up two different equations. We're going to do one equation exactly the way it is without the absolute values. The other one, we're just going to change this to a -5. Because I see here that if I have a 5 in here or -5 in here, both of those are going to give me an answer of 5. So I have two answers on this. That's why I got to set up two different equations for that. Let's go ahead and solve this by adding 4 to both sides. Oops, let's do one at a time. We'll do this one first. X equals 9. If I add 4 to both sides here, then I get -1 for that one. And so now I get two different answers. Of course, if there's a 0 in there for y, that means I'll write my answer as 9, 0 and -1, 0. So this time I get two x-intercepts that I get for this particular one. So 9, 0 and -1, 0 are the answers for this. Okay. Next, for the y-intercept, put a 0 in for x and solve for y. That's the instructions. So let's follow that. We're going to do y equals absolute value 0 for x and -5, like that. Let's simplify this. Absolute value -4 minus 5. Absolute value of -4 is +4, but I still have a -5 on the outside. 4 minus 5 is equal to -1, which means then coordinate form, a 0 went in there for x, and I have -1 for y. And so that would be the answer. Separate that here. So this is the x-intercepts are 9, 0 and -1, 0, but then the y-intercept here would be 0 and -1. And so that's as far as I want to go today with that. So just want to do just a little bit of 1.2 for you, just to get that started. Of course, there's some more examples that we'll be doing later. This is getting into graphing, so we'll do all that tomorrow. I just want to focus more on the algebra stuff for now with it. So with that, I'm going to go ahead and end the class right now. But if any of you have any questions, you can feel free to stick around, and I'll be free to answer any kind of questions that you have. And so does anybody have any questions? If you don't have any questions, you can feel free to leave this meeting. That's okay. But if you do have any questions, let me know.
Quick question. So for the first example that you gave us, and there was two solutions to it, why is it that for the second one, when you put in 0 for x and solve for y, there's only need for one answer versus two answers?
Okay, because basically it depends on if you have if you're taking a square root or not. That determines if you have more than one answer. This question here with the first example, we ended up with a y squared equals 4. So if you have a square on that, automatically when you take the square root of both sides, you do get a plus or minus. That's what gave us two answers. But the second time when we went down here, we just put -4 in there and we're taking the absolute value. When you take the absolute value, you only get one answer. You're not going to get two different answers out of that. The absolute value -4 is just 4, which can be verified with a calculator. So that's the reason why we did not get two answers on that one, because we did not have a square on that one. And we did not have to take the square root of both sides. And that prevented us from getting two different answers.
Okay, thank you.
Yeah. Other questions out there? All right, sounds like there's no questions out there. If you think of something else, feel free to send me an email. I'll be happy to answer that for you. But I'm gonna go ahead and end this meeting now, and I'll have the recording up there, within, but it should be up there soon. You'll be able to see it. So with that, enjoy the rest of your day, and I'll see you guys back again tomorrow. Have a good one. Thanks for attending today. And I have Jessica has a question. Yes. What's your question, Jessica? Oh, for the x-intercept, the reason why there's two answers for the first one right here that's on the screen, that's only because it's an absolute value. And absolute values always require you to set up two different equations for it. It's a unique one. We didn't have that in the first example, because the first example, when we set that up, the square went away, and so we just got 4x equals 4. So that can only be one answer on that. But what makes it different this time is you've got the because it's specifically an absolute value, that tells you, so if specific, whatever function that you actually have, that determines whether you get two answers or one answer. So as long as you solve it correctly algebraically, it'll automatically let you know whether you have one or two solutions. But absolute values like this, the only way to solve them is always setting it up into two different equations like this, one with a positive 5 and one with a negative 5, and that's why you got two answers on that one. It's only because that's the right algebraic process in order to solve an absolute value. That's the reason why we get two answers on this. We didn't get it on this one, or the first one, because there was no absolute value, and that's why we only got one answer there. And the only other one where you get two answers would be with a square. So you get two answers if you have to take the square root of something, and you also get two answers if you have to solve an algebra problem with an absolute value. Then you get two answers for that as well. So that's the only case where you would get two answers. Otherwise, if you don't have either one of these in there, then you're just going to get one answer. So hopefully that answers your question. All right, so with that, I'm going to go ahead and end this meeting now, and I will see all you guys tomorrow. Again, if you have any other questions, please feel free to send me an email and ask, or you can even ask if you think of something later. You can always ask it tomorrow, and I'd be happy to go back to that as well. But enjoy the rest of your day, and I will see you guys tomorrow. Have a good one.